All right, let's just jump right in. If you're getting ready for the digital SAT, you are absolutely going to run into systems of linear equations. It's not a question of if, it's a question of when. So in this explainer, we are going to crack the code on how to solve these things fast and feel good doing it.
So here's the classic puzzle, right? You get two equations, something like x plus y equals 5 and 2x minus y equals 1. Now on their own, each of those has tons of solutions, but put them together, suddenly there's only one single x and y that can make them both happy. The real question is, how do we find that magic pair without just guessing and wasting a ton of time? Here's our roadmap for today. First, we'll get a handle on what these systems actually are. Then we'll load up our toolbox with two powerful methods, substitution and elimination. After that, we'll talk strategy, how to pick the best tool for the job. We'll even cover the weird cases, one, none, or infinite solutions, and finish up with a solid game plan you can take with you on test day.
Okay, first things first, what are we even talking about here? Let's break down the core problems so we know exactly what we're trying to solve.
A system of linear equations sounds super technical, I know. But really, it's just a pair of equations that are linked together because they share the same variables, usually an x and a y. The whole point, the entire goal, is to find that one specific x and y combo that makes both equations true at the exact same time. Think of it this way. For an equation like x plus y equals 5, you could have 0, 5, or 1, 4, or 5, 0. I mean, there are literally endless pairs that work. Same thing for 2x minus y equals 1. But our job is to find the one single pair of numbers that works in both. That's our target.
And spoiler alert, for that specific system, the solution is the point 2, 3. If you plug in x equals 2 and y equals 3, you'll see that both equations check out perfectly. That single point is what this is all about. It's the treasure we're hunting for.
All right, time to grab our first tool from the toolbox. This is the substitution method. I like to call it the secret identity method. It's kind of like one equation gives you a clue about a variable's secret identity, and then you use that secret to go and crack the other equation wide open.
So the whole goal here is to get rid of one of the variables, just for a little while. With substitution, we figure out what y equals in one equation, and then we take that whole expression and just drop it into the other equation in place of y. And just like that, a two-variable problem becomes a much easier one-variable problem.
And the process is always the same, just 4 simple steps. 1. Get a variable by itself. 2. Substitute that thing into the other equation. 3. Solve the new, simpler equation you just made. And 4. The final step, take your answer and plug it back in to find the variable you started with. That's it.
Okay, tool number 2. This is the elimination method, or as I like to call it, the cancel out method. This one is really clever because it's all about making one of the variables just poof, vanish.
So instead of swapping things around, with elimination we just stack the two equations on top of each other and combine them. By adding or subtracting them, we can strategically set it up so that one of the variables completely cancels itself out, leaving us with a nice, simple equation to solve. So here's the playbook for elimination. First, line up your equations. Then, look for variables that have the same number in front of them, or even better, opposite numbers, like a plus 2y and a minus 2y. If you don't see a perfect match, no big deal. You can just multiply one entire equation to create one. Then you add or subtract to make a variable disappear, solve what's left, and plug that answer back in. Done. Okay, so we've got our two tools. We have substitution and we have elimination. But on the SAT, you're on the clock. Speed and strategy matter. So how do you know which method to pull out for a specific problem? Let's talk strategy.
This chart basically makes the decision for you. You want to use substitution if you see a variable that's already all by itself, or if it has a nice, clean coefficient of 1 or -1. It's just cleaner. On the flip side, if your equations are all lined up and you spot terms that match or are perfect opposites, elimination is almost always going to be your faster bet. Making the right choice here can save you a ton of time.
So far, every problem we've talked about has had one nice solution. But you know the SAT, they love to throw you a curveball. What does it actually mean when a system has no solution, or even infinite solutions? Let's see what's really going on here.
This is the normal situation, the one we see most often. If you think of each equation as a line on a graph, one solution just means the two lines cross at a single point. And that always happens when they have different slopes. Makes sense, right? Now, what if the lines never, ever cross? Well, then you have no solution. Think of them like parallel train tracks.
They run alongside each other forever but never touch. In algebra speak, that means they have the exact same slope, but they start at different spots on the y-axis.
And the last case is kind of a trick. You get infinite solutions when your two equations are secretly the same line in disguise. They might be written differently, but if you simplify them, you'd realize they have the same slope and the same y-intercept. Every single point on that line is a solution because it's the same line.
Now here's the best part. You don't have to draw a single graph to figure this out. The fastest, easiest way to find the number of solutions is to just rearrange both equations into the good old y equals mx plus b format. Once you do that, you just compare the m, the slope, and the b, the y-intercept. That's it. It tells you everything you need to know.
Okay, let's pull all this together into one simple, powerful game plan. These are the key things you need to have locked in your brain when that clock starts ticking on test day.
This right here is your ultimate cheat sheet. If the slopes are different, you've got one solution. End of story. If the slopes are the same but the intercepts are different, no solution. And if the slopes and the intercepts are the same, you're looking at infinite solutions. Your secret weapon to figure this out every time, get them into y equals mx plus b. It is the master key.
And just remember this. These problems can look a little scary at first, but they are 100% a skill you can learn and master. It's really just about practicing and knowing which strategy to use. You've got this.
So now you have the tools in your toolbox, substitution and elimination. And you've got the guide for when to use each one. Now the ball is in your court. It's your turn to get in there, practice, and really own these skills. So, which one are you going to master first?